we are going to use the power series to solve this differential equation. So for differential equation using the power series, first we just write the function y is a power series of x. So it will be, I will write y equal to the series, the power series when n go to 0 to infinity. And then because the equation has up to second derivative, so we take the first derivative. The series now will go from 1 to infinity. Derivative of an x to the n power is a sub n times n x to the n minus 1. And we take the derivative of that. We have the second derivative. The second derivative, I'll just take the derivative first. So a is n. Derivative of x to the n minus 1 is n minus 1 x to the n minus 2. And this one starts with a1 constant. Derivative of a1 is equal to 0. So the non-zero will start from 2. So we have all the derivative. And now we just substitute into the equation. We have x squared plus 21 times the second derivative. Now I use the series. That's the second derivative, plus the function right. Now I multiply the x squared to the second derivative and then 21 to the second derivative. So I should have, if we multiply x squared I forgot the n here, sorry. That is the second derivative, a sub n times n minus 1, sorry. That is the second derivative. We multiply by x squared. Multiply x squared, we can just do that. And that becomes just x to the n power. So I'm just going to say it x to the n power when we multiply by x squared. And then when we multiply 21, I'm just going to write 21 inside of the summation. A sub n times n minus 1 x to the n minus 2, and then the series for y. Right, now all of them on the series. Now we just need to combine them. It's very important to combine the series. All of them have to start at the same index. Here we don't. 1 is equal to n equal to 2 and 1 equal n equal to 0. Right, so not only that, they have to have the same power of x and start the same thing. So first we check where it starts. When n equal to 2, when n equal to 2, if we put 2 in for n, this series we start x squared. The next series, when n equal to 2, that series start at x to 2 minus 2. So this one x to the 0. So pretty much a constant. And same thing, this one will start at x equal to 0. constant. Right. In order to combine them, everything inside each series have to be the same. So in that case, we have to make all of them start at x squared. So the first one is okay. It will stay the same. I should start to write more compact now because take more space. Right, for the next, the middle series, we need to make it start at x squared also. So when n equal to 2, now let n equal to 2 for a moment. N equal to 2. We're going to have 21 a2, 2 times 2 minus 1. So times 2, 2 minus 1. X to the 2 minus 2 will be 0. X to 0, which is, so when n equal to 2, we have this term, of course, that is just a constant. We would not be included in the power series. Next, we let n equal to 3. We just increase the index. So when n equal to 3, we have 21 a3, n is 3, 3 minus 1 is 2, and x, 3 minus 2 is 1. So remember, we want x squared in the summation. We have a constant, and the first power of x should be outside. After that, the series will be good enough. It will start from 4 now, because we have 2 and 3. Now we go to 4, from 4 to infinity. And that's 21 an n minus 1 x to the n minus 2. Right? Now we go to the last summation. Actually, that one is not too bad. We can just say when n equal to 0, we have a of 0. When n equal to 1, we have a1x. And when n equal to 2, we have the series start from x squared. Right? So that's what we have. Now, I will write everything that not under the summation inside. I write those terms first. Right? So 21 times 2, so there will be 42. There's more space here. 42. A2. And then plus 21 times 6. That will be 126. X plus a0 plus a1x. Right, so that's everything that is not under summation. Now for the summation, even though all of them now all the series start at x squared now, but the index is still off. We have n equal to 2 and n equal to 4 for the summation. So it's not quite, won't be able to add them yet. So what I'm going to do, one more step, is we're going to change, we just fix everything to x to the k power. So this is supposed to be x to the k power. So for that, we let n equal to k. And that's good. So the first series, instead of n, we're going to have k. K equal to 2. And we have 2 to infinity, a sub k. K minus 1. X to the k. So that first series is that. The second series, notice that this time we start at n equal to 4, and the power here raised to x to the n minus 2. So if we make this equal to x to the k as well, for that we should have k equal to n minus 2. So n is equal to k plus 2. So that series become, now is n equal to 4, and n is equal to k plus 2. So if we translate, that would be k equal to 2 equivalently, because n equal to 4, k plus 2 equal to 4, so k is equal to 2. We have 21 a to the k plus 2, because that is n, k plus 2, k plus 2 minus 1 is k plus 1, x to the k. Now you see that we do have, starting from k equal to 2, and we do have x to the k. Certainly we can combine the series that way, not before. Right. And the last series is easy, because we don't have to do anything. We just say if this is equal x to the k, then n is equal to k. So we just rewrite that using k equal to 2 to infinity ak x to the k power equal to 0. Sorry, careful now, space there. Right. Now we'll combine like terms and then combine the series. First, there's a constant here and here. So we will write a naught plus 42a2 plus why is that just 126 here? It's missing something, right? Sorry, this term. It should be 126 something. Right, that 126 is come from here. So that will be A3. A3x. So we have 126 A3. We should have a coefficient there. And then times A1 power of x, right? And now the series. Now, if we put things, factor out x to the k power, we will have a k times k minus 1 x to the k, that common term going outside, plus 21 a to the k plus 2 k plus 1 k plus 2, and then plus ak, all of which multiplied by x to the k equal to 0. Now, because the right hand side is equal to 0, all the coefficient must be 0. So we have this equal to 0, and this equal to 0, and all of this equal to 0. Right. Now just write down what we have. We don't know what a naught is equal to, so we just say a naught is equal to a naught. A1 is equal to a1 because there's no restriction there. Now if a naught plus 42 a2 is equal to 0, so a2 must be equal to negative 1 over 42 a naught. And a3 is equal to negative 126 a1 times a1. And then what else do we have? If we need to go further when k equal to 2, we actually don't need to do that, but let's say when k equal to 2, we're going to put k in this equation. We will have A2, 2, 1, plus 21, A4, k is 2, so it'll be 3, 4, and k is 2. And suddenly this has to be equal to 0, and from here we can solve for A4 equal to something. But the question did not ask us that. Thankfully, the question only asks us to find the solution in terms of A0 and A1 and up to x cubed only. So only up to x cubed. So we will say the solution equal to y equal to power series n equal to 0 to infinity a n x to the n power, which means a0 x, a0 x, a1, a0 is a constant, a1 x, a2 x squared, and a cube x cubed, and so on. But we have a0 is just a0 because we're not sure about that constant. We are not given anything about that constant. We know a2 is negative 1 over 42. a0 x squared minus 1 over 26. a1 x cubed. And then the series goes on. But we only need the first term, the first 4 terms. The term that end with x cubed. So let me zoom out. So we have the whole picture. So we just write a power series and then combine the series. When we combine, there are 3 things we need to do. First one, we have to check to see where the series start. If they don't start the same thing, we have to split. So we have to split. This is where we split outside of the series, so that all of them will start at the same power. So we have to split if we need to. So the second step maybe we need to split out a few terms so the only series start the same thing. After that, we do the transformation from n to k, because after that everything has to be in the same power of xk, and all of them start at the same k. Only then we can combine this, the series. And after that, undetermined coefficient, because the right hand side is 0, every coefficient on the left hand side has to be 0. And from there we can solve for the coefficient.